Hello, it's Matthew Yeseda. Here we go on marketing mix attributions. This is in Python to help improve marketing mix and everything else that we do. Okay, so here we are. Now we're going to talk about revenue growth and marketing mix analytics and the stuff we did at Snowball. Snowball was leveraging marketing mix model. This was used as a cutting edge solution. We drove revenue. We helped customer loyalty to build that and utilize the team to advanced statistical machine learning models and marketing mix analytics evaluated the precise impact of each marketing channel on improved sales. That was great for the campaign. And this approach empowered our business that we were able to do the marketing spend and optimize the marketing spend and focus on high performing strategies and high performing customers and achieve a balance between short and long term growth and make sure that these solutions for executives to help them make smarter decisions so they can work on better and hence return on investments and create meaningful connections with our customers and drive more better loyalty and retain customers and reduce the churn. Now we talk about how marketing mix analytics is used as a powerful strategy. It helps your business uncover each of the marketing channels and the best marketing channel to put the budget to. This contributes to revenue, of course, and by analyzing market channel effectiveness, marketing mix analytics allows customers to make data decisions, more optimized marketing budget strategies, and focus on high performing strategies. Marketing mix attribution, we're going to show you what we did on multiple algorithms, LSTM, Shapley, and coefficient, that we use these to demonstrate how to maximize our revenues, but also to enhance customer retention and loyalty and ensure that, not only our marketing team, but also us as the developers and resonate with the customer audience. We're going to talk a little bit about some Python coding, basically just setting up the data set and splitting it for marketing mix. It's basically just doing a data frame, getting the features that we need, and then setting up a random forest for marketing mix feature importance analysis. This is for channel contribution. Use random forest for that. Did the fit model, and then we got the importance by the columns that we wanted for importance, and then we reported it. Simple enough. We can over and over and make sure we get the right thing. Next, we're talking about more details on the Python coefficients and the marketing mix attributions and plotting these contributions for each channel. Here we basically have a data frame with columns that have the contributions, similar to the importance field earlier. We sort the values, then we have then we can plot them so we get those things. And then we have the salespeople look at them. And then we do a marketing spend optimization, work with marketing people for fair attribution. Then coefficients, we divide that by the means, and then we get our recommended spend, and then we get our sales mean, and then we got our explainer, Shapley explainer, to help the shape values, and then we'll have to plot that, of course, and then we'll be in business. We're going to talk about the Python LSTM marketing mix that we did for Europe and South America customers. We basically set up a LSTM model. We used the sequential, the LSTM. We got our parameters and shape and everything and the sequence and LSTM, the dropout and density. Then we compiled the model. I used an optimizer atom and a mean square area for loss function. And then the model was fit on our with epics. You have to test the number of epics to get the best size and the batch size and the split and all that. But then you get a prediction model. Once you get that, you're good. Longer epics sometimes work better. You just got to play with them. And then the conversions for the predictions, and then we create a scalar, but we inverse this on the transformation using an 8-stack, and then we got ourselves a reshaped prediction model. We're good. Then we have our Shapley model, and it's a form-forward neural network for feature attributions. This is going to identify the channels that have the most conversions. So we're going to get our Shapley model, we're going to set it up with a ReLU activation, and then we're going to do our necessary components and parameters. And then we'll get the model, we'll compile it with an Atom and a MSE, again, just like we did with the LSTM. And then the Shapley model will have a fit and a validation. Again, you gotta experiment and get the right epics and compare models. And then we have the shape explainer, and then we have that on the train model, and then we're ready to go with a summary plot, and then we're in business. As you can see, we had features, a TV and budget and search. You can do other things. We'll talk about that later. So let's go over a little bit on the coefficients and how it worked and the objectives and the key outcome. The objective for this coefficient was a regression coefficient model to determine contribution on each channel. And the key outcome was the contribution and analysis of each spend on each optimization. Steps for coefficient was to extract the features from the train model, visualize in bar charts for impact features, calculate return on investment, contribution and average spend, and trade-off optimize for spend on return on value. If we're talking about on the next one in the Python, it's LSTM model, the attribution and objectives and the key outcome. Here's the key outcome objectives. We have both long-term memory. This is to model time-dependent marketing data, and that's a pretty easy tool to work with. And then the outcome is to handle patterns and provide insights into temporal marketing sales impact strategies. LSTM steps are basically build the LSTM model with multiple sequential data analysis, train the model on historical market and data and predict futures, and then generate predicted conversions on attributes in real world matrix, and then you visualize it. Next, we're going to talk about the Shapley. This is the last one, and its attributions and key values. The objective again here is for importance using Shapley values in neural network model, and we get the impact, and the key impact is transparent and explainable attribution conversions. This is for specific market channels. Shapley values are trained for the form feedward neural network for conversions based on the market spend. Do an additive explanation to compute the contributions of individual features to visualize each on the platform. These are the ways we can do it, and I'm ready to help you in all these roles. Thank you very much.